Welcome. This is the last task in Module 6, 6.9, and they use the analogy of water wheels, and they're comparing that to the unit circle. These are water wheels here. They're used to power flour mills before electricity. They use the power of the spinning wheel. And one of the requirements is that these particular ones each have 12 spokes, and they're saying that the spoke is 1 meter long. So that sounds a lot like the unit circle with a radius of 1. Okay, it's in terms of meters. First thing they want you to do is to find some angle measures. Before we do that, let me go back and review. We've talked before about 30, 60, 90 triangles. They have a ratio of 1 to a half. That's the side opposite the 30 degrees. And that side times the square root of 3, square root of 3 over 2, opposite the 60. We also talked about isosceles right triangles that have 45, 45, 90 degree angles. If the hypotenuse is 1, then the other two sides are square root of 2 over 2, and that's because 1 divided by the square root of 2, if you multiply both sides by the square root of 2 over the square root of 2, you end up with the square root of 2 over 2, and you've rationalized the denominator. So, using that, let's see what we can do. First thing, let's start with the angles. 90 degrees divided by 3 equal parts will give us 30 degrees. So the measure of angle BAC is going to be equal to 30 degrees. It's also, if you think about 2 pi as the number of radians in a circle, therefore pi radians is half a circle and pi over 2 radians is a fourth a circle. You can see that it is 1/3 of pi over 2, which is equal to pi over 6. So we can also represent it in terms of radians as pi over 6 radians. Okay. On the second circle, when you look at the angle, you've got 90 divided by 3 is equal to 30, but we have 2 of these, so 30 times 2 is equal to 60. So if we're looking at the measure here, the measure of angle BAC, it's going to be equal to 60 degrees. And if we look in terms of radians, if pi over 6 is the first, this one must be 2 pi over 6, which is the same as pi over 3 radians. Okay, so each of these arc lengths are pi over 6, and we can use that to calculate going all the way up where 0 is equal to 2 pi radians. So then you can label some of these. So let's start with what we know: 0, pi, pi over 2, 3 pi over 2. Okay, and then we just did pi over 6 and 2 pi over 6, which is pi over 3. So using this, we can actually figure out the rest of these. Let's call pi over 2 3 pi over 6. And without simplifying, we can say 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, and 12 pi over 6, which is 2 pi. So that represents the radian measure, although I haven't simplified those. They also are looking for specific points like xy values. So really, you can use these two as a reference triangle, which is really the same triangle, right? Just different angle of reference. And on pi over 6, we know that if the radius is 1, we know that the side opposite the 30 is going to be a half, and the other one's going to be the square root of 3 over 2. So this is our 30° is our angle of reference. So the y value in this one is going to be a half. So the x value would be square root of 3 over 2, 1/2. It would be the opposite. Let me do a different color for the next one. It would be a half square root of 3 over 2. And then it's different in the case of pi over 2 because x is 0, y is 1. But when we look at 4 pi over 6, we can see that the height is the same. So the y value is the same. The x value would be negative. So here we can represent, as negative a half square root of 3 over 2. Same thing on 5 pi over 6. Note that the height is the same. So this one is negative square root of 3 over 2 half. Pi is at negative 1, 0. And then we can do the same thing for the bottom half here, where you can see that the x value is the same between pi over 6 and 11 pi over 6, so it's going to be square root of 3 over 2, but the y value is negative, so it's going to be negative 1/2. Okay, over here, you can see that the x value is going to be the opposite of that, so negative square root of 3 over 2, negative half, and then we could keep going and do the rest. I guess we can. 0, negative 1, and then we've got 10 pi over 6 is kind of like 2 pi over 6, but it has the same x value of a half, but it's the opposite of square root of 3 over 2. And then we can see that 8 pi over 6 is the same thing, but the opposite of the x value, negative square root of 3 over 2. So therefore, we've got all the positions on this particular